Okay, let's stop doing that, and we will go back to the wonderful wild world of generics in Haskell. We are on chapter 13, and we are, if I remember correctly, we're doing something with JSON schema, and I don't even remember what, so we'll get there in a little bit. Why did it just say welcome to the chat room again? I don't really know why it does that. Moobot's a little problematic at times. Okay, so what do we got here? G schema. Oh my goodness. I forget how wild this code was. Okay, here's this code. And okay, so this is like, oh yeah, we were gonna implement some of these functions that we don't understand and go see what they do and then try and go from there. That's basically what we were doing. A lot of this stuff has been given to us by Sandy, so we'll just trust Sandy for now, and we'll hopefully get somewhere useful. But this code is insane to me. Not support some types. Okay, so we can support product types, but not some types apparently. So to do some types, we do this thing where G schema equals error JSON. Why do I write this twice? Seems strange. So this looks terrible, doesn't it? Oh yeah. I don't think it was long enough for you not to see it, but it's a lot easier if you can just see it. Yeah, so anyway. So let's see here. So if we have a sum type, essentially what we need to do is print the schemas for each of the types and then merge them somehow. Where does this merge objects come from? Yeah. So there. So we have basically two JSON objects or JSON schemas in some kind of string format, and then we merged them. Weird. Okay. So it says, because some types are not allowed, information about data constructors isn't interesting to us. We simply lift a gschema instance through M1C metadata for data constructors. I think one issue I have here is that I really don't understand all of these things, and we've used a few that weren't explained, or at least I don't think they were explained. So I have a hard time realizing what I'm supposed to be doing. G schema at A. And then we need to apparently aggressively inline both of these. I think that's what that would mean. Okay. Phone's blowing up. Hang on 1 second. This is insane. Convenient. Okay. Earlier today we had some funny issues at work, so turns out it was in fact a really stupid issue. Oh my goodness. Um Okay, I'm just gonna keep going. I don't really know how I feel about this thus far. This is kind of weird. So, you guys want to talk about something else? Let me know, and we can just talk about stuff. But I do want to get this on paper. I see what he's doing. He's doing 2 tabs. Actually, that's kind of clever. See, like none of these symbols just mean anything. I really wish they were something else. Maybe like A. Yeah, so we should do. This is fine. Okay, so G schema do SCH. SCH. I have no idea what that means. Suppose I could just copy and paste this. I'm hoping that typing it will like get me somewhere. I'm not sure it is. String pack symbol val proxy. I mean, I know what these things are. Is that something? But I don't know what, like, I don't know what this is. I can go look at the type, I suppose. Maybe it will mean something more. Oh. SCH. And what's A? Something about the metadata. NM. What's NM again? Hang on. N. Okay, so NM. I don't know why it's NM, but I think that that's essentially the type. The name? I'm gonna guess that NM stands for name here. So this here is the name of the class. So that's the title here. So whatever the title of the class is, then we call it an object. So I guess this is anything it doesn't understand. And then its schema comes from A, which is what again? An M1. M1. What is an M1? I don't remember what M1 stands for. M1. Does anyone remember? Or no? I feel like you wouldn't remember from what I said last time, but maybe you just know what it is. I found the metadata. It takes 4 things. But I don't know what M1 means. There's something up here to hint what M1 is. Not really. Oh, maybe this is like the... Okay, so this is actually a D. I get it. I think I get it. So a D... Hang on. Just was looking at a D. So A is just a unit type. So it's converting the no, not unit type. It's just converting the constructor to G schema, I guess. And it's just the name. We'll see what it looks like in a little bit, but these symbols are really hard for me to parse because I'm not familiar with enough with them to understand this. Yeah, okay. So anyway, it says finally we need to run our writer list of text and transform that into the list of required properties required. We'll use the opportunity to also act as our interface between A and rep A. Okay. So schema for all A dot G schema rep A. This is really hard. Maybe I'll get this someday. I'm not really sure. Here, let me move this up. I keep forgetting. I'm sorry. Value. I think. Yes. Run writer G schema at rep A in merge objects B object required. I don't know what this part means. A from list string x. Okay. Oh. Ah. Uh, okay. So supposedly I can use schema already on the person type. How do I do that? I don't need to do what I just did. I gotta get out of that habit. So how do I use it? Do I? Oh, right. We were doing something else last time, so it's not gonna be like immediately available. Let me go look at the example here. So I just need to... Hello, everybody. There's a few new people, so I'll say hi. If you want to have a chat about something, probably not related to Haskell generics, because this is really hard, you know, feel free to bother me. So I think we just do something like this. It produces a value. Right. Set X type applications. Whoa! Just did something. I honestly was not expecting that. I think I vaguely remember us being able to pretty print this, but I don't remember how we did it. I think that there was some sort of encode function in JSON, or excuse me, in ASIN. So encode, and we want to look, not JSON, we want to look for ASIN encode. So we can just do an A to a byte string. So can we just do... It doesn't look like we have encode, so import data. Where's this from? Just data ASIN. Data ASIN. And then we want to encode this. Okay. And then what do we have now? Do you want to take a byte string? Ready? Does anyone know of the function? I mean, that's the string, but I'm hoping to pretty print JSON. Well, we can just do, we could try and just look that up. So we want to look up byte string to IO unit. Put stir. Okay. So we're gonna get it from... Apparently we need to get it from here, but I think we can just get it from here. And we need to do it from lazy, so we gotta do it from here. So, import qualified data byte string lazy as lazy byte string. Can I please? Can I just have? So we can do lbs dot put stir what happened? Also, hello new viewer. How are you? We're trying to figure out how this how to pretty print JSON to the screen essentially. But I can't quite figure out how to do it quickly anyway. Cuz I don't know what I'm doing most of the time. It's kind of how that goes. Oh. Isn't that what I call it? But that's not gonna, it's not gonna get the thing I need unless I just quickly put that in here, which is probably fine. Main import JSON EEMA. That's, yep. And then foreground. There we go. So then, should be able to do this. Put Sterling. Interesting. Okay, so it does say use this thing, which is fine, I guess. We can do .car 8 as LBS. How do I unimport something? Fine. C. Okay, so it's not pretty printed JSON, but it is getting it right, it looks like. So let me remind you. Thank you. Also, hi, Simon. How are you? Oh, person. So if I do minus I guess I do it this way? Or do I need an M? Nice. And then dot. That'll take those, and then I can do... I should write this stuff down. But I never do, and then I forget. So then this can just be LBS. Okay, so that's pretty darn close to what we need. Again, it's not pretty printed, but I think you can pretty much see what's going on here. So it just tells you essentially the following things: that a person is an object, it has a title, and it's going to have required fields: name, age. Oh yeah, info, person. So name, age, phone, permissions. Yeah, well, actually, we're building JSON schema from scratch. I don't know if this package might already exist, but we're basically using Haskell generics to build a JSON schema package. I don't know, it probably already exists on Hackage or something, but I think it was Illumi last week, or someone was basically mentioning that they don't think that this is the proper approach to do this. Like, there's better ways. But you know, we're trying to learn about this generics thing, so we can see that this is working, but it's quite difficult. Also, just noticed something. A phone number is just a maybe, which seems problematic. It's not a maybe string, it's just a maybe. I don't really know how to fix that. Maybe we will. Maybe we will in a little bit. But you can see, like, it's doing okay. I mean, it's getting, you know, it can't do array of bool. This is kind of weird to me. I mean, it's getting part of the data constructor, just not the whole thing. We might be able to figure out where this is. So give me 1 second. I might be able to tell you. Z. How many? Okay, so Vim. Yeah, so this is basically what our code looks like. It's basically, you know, 10% language extensions, and then 10% imports, and then, you know, 80% code. Yeah, so you can see here, like, it has no concept of maybe. So it just sticks maybe in there. I'm surprised it doesn't say maybe string, but I'm pretty sure that this is the code that's running. Unless somewhere else it's dealing with maybes, but I don't think it is. Yeah, so I think that that is happening here, and for whatever reason, it can't deal with maybe here. I wonder if I could just write, like, excuse me, maybe a? Probably not, but we can try it just to see if my logic is correct. Yeah. So maybe. Oh, it might work. Let's see. Ah, I saved. Shoot. Trying to get better about that. So we need to reload, and then we should just be able to do this. So if I info phone. So instead of giving you a oh, well, it gets you to a string, but it gives you an actual value, which is weird. So I'm not sure what to think about that. I was expecting it to say string here, but I mean, that is an empty string, but that's not what I was expecting. Okay. So let's go look at that again. I don't so rep name rep t. So we're basically giving it a string. What if I recursively call to JSON type? Then I'll fall through to string and get string. But again, it's not quite right. But maybe we can write the following. Maybe. I'm just thinking out loud. I don't know if this is actually going to work. What if we did something like this? How do I concat these together? So these are symbols. I'm sure that there's a way to combine symbols. I just don't know what it is. So, oh. Ah, did that. That's not what I mean. We gotta go searching. I am sure that there's a way to combine two symbols. I mean, there has to be, right? Really want is exact, I think. How do I make it not generic? Hmm. I feel like we've probably done this before, I just don't remember how to do it. What if I look for generic in here? Is that a thing in here? Yeah. Alright, so it's just in Prelude? I don't know where these are. If I just look up GHC generic docs. Yeah. Okay. This is not in here though. This will be with where whatever symbol is, which is a typelet. All right. So what can we do with typelets? Um, I have no idea how to do this. How about Haskell? Combine two symbols. We can't concatenate two strings, I don't think. What about, can we do this with a first class family maybe? First class families? Is this something that you can do here? So this seems to implement an error. I wonder if we can use that to our advantage. So, I guess message here is, I don't have a constructor though. Hmm. I have no idea. There's got to be a way to do it. I feel like there has to be a way to do it. I don't know. Um, hmm. I mean, I can't just add them together. Well, let's see if this works first. Like, maybe this doesn't even work. Um, Reminder. That works. Although, is is anything that's a maybe just an object? Because it's not, I mean, it's not a string really. It's not an array. It's really an object, isn't it? It's not a known type. I'm a little confused about that. I don't know enough about JSON schema to like have an opinion. Um, but it seems to me that type name A is really not correct here. And it should be something else, but I don't know what, because I don't know how to combine two symbols. Maybe I can. This is just converting it to text. It's a kind. There are instances of the class for every concrete literal. What if can I wish I knew what to do. So like, you could require that every A. Wait, no, you can't. I think I'm gonna have to ask Reddit or Stack Overflow or something, because I really don't know how to. I wanted to say maybe string is what I wanted to say, just because it will make me feel better, and I think it would be cool. However, I have no idea how to combine two symbols. Yeah, that's the thing, is I don't know. I don't know enough about them. What if we go? What if we do the following? I keep doing that. I'm trying not to, but it's not working. What if we go look at some of my first class family stuff from before? Give me a second. I just gotta remember what chapter this stuff is. We did some interesting stuff in 12. I think it's in here. What are things that we do with a key? So here, a key is a symbol here. And what do I do with key? I just embed it in text, and then this is how you print keys out, for example. So this type family is a custom error message for requiring that a key is unique, essentially. That was a little crazy, but it doesn't have like this one has symbol in it. So this one is testing that the element exists. So it looks to me like I can somehow create a first class family that combines symbols by just concatenating them, maybe? So let's try that. Type family concat symbols. I don't know what to call it. We'll just call it that for now. And then it's going to be like do so I don't know what to call it. We'll just call it first, second, and its return type is symbol. So concat symbols first. Can I use the same names? Yes. First, second equals eval and we just need to combine two strings. can I just combine them? Not quite. Oh, I can't, hang on. This one doesn't define a return type. Where do I get eval from? This is used for custom error messages. So in this type error thing, you can actually build custom error messages that say, like, what this does is aligns to the right underneath this string, essentially. So like you're writing this string, and then this combinator basically puts the function name, you know, to the right of that string right here. I can't highlight it because there's no spaces there. And then you just keep going over to the right until you hit this $sign one, and then that gives you a new line. So this is what like custom error messages look like in Haskell. They end up being, yeah, it's like, it's really wild. That chapter was really hard. Really hard. All right, so what's eval? I forget. Where does that even come from? I think it probably comes from first class families based on what we're looking at here. So let's try it. FCF. We don't have that, so we need to add it. Add GHC as a dependency. I don't think we want to do that. So Z. 16G. Yeah, this book is really awesome. I'm definitely getting into the really hard stuff where I don't follow everything, but I'm still learning things. And like, I keep doing this thing where I meander and try new stuff, and I feel like I'm learning a lot because of that. So like, you know, don't just read the book. I think you're a better Haskeller than me anyway, so like, you can find really nice ways to meander and learn some really interesting things. Oh, since you're here, did you see my updated PR? Are we gonna have something to work on Thursday? If you didn't see it and you don't have time, obviously don't worry. It's just asking. Oh, awesome! Thank you. I was pretty happy with it. We had a lot of fun with that, or I've had a lot of fun working with that. So, well, not here. I forget which one it is. That should go away. There it is. Okay, nice. Now, what's going on here? Okay, so we basically need a situation where, not this one, because this is, we need a closed type family that works with a symbol. And essentially this works with a symbol. We need a first class family to combine stuff. So let's just look in here. My goodness. Okay, that's fine. So, the problem is the only thing in here that takes a symbol is an error, which is a problem. Because I have no... How do I get a symbol to a string? I think it's... How do we just print it here? I don't understand. How does it know to do this? Where does that text thing come from? Man, I'm confused. Oh, that's in typelets. Ooh! Hell yeah. Found it. Append symbol. We did it. Hell yeah. So let's go look at the source code for that, because obviously we... Whoops. We done with this? Yeah, I think so. So wait a second. Now I'm a little confused. Because... Oh. I searched for a function. Can I Google stuff like this? I don't know. How do you Google stuff like that? Can you? I have no idea. Wait, how does this work? There's nothing here. What? Hello? What? Doesn't it need to do something? Uh... Doesn't do anything. I don't understand. So this is just an interface? Where's the... Where's the implementation? Well, this is cool. I've never seen this before. Physics? Ribbit? Type expression. I really don't know. So I don't know the answer to that. I'm a little confused. I might have to ask somebody about this because I'm a little flabbergasted. So it's like it says, you know, this is an internal GHC module. It declares the constants used in the implementation of type level natural numbers. We're not using type level natural numbers, but maybe it's defined in types. I'm not sure. I think I'm gonna leave this to just like asking somebody because I could use some help with this anyway. This is literally uses of it. This isn't, although maybe first class families, it doesn't seem to. Yeah, I'm not sure. I really don't know. Either way, it's interesting. Somehow this is all seemingly defined. So let's see if this actually works. That would be really cool. Uh, shoot. Right. That's gonna undo everything, so to hell with it. Start from scratch. Set X type applications. Lazy byte string. I need to do this anyway? It's fun. So then load app main. And then this. And then should work. And then moment of truth. Oh, yep. That one's not so bad. Yeah. Nice. So anyway, this kind of works. So that's cool. And all we needed to do is find this embed symbol thing. I suppose we just make this lowercase. Anyway, I'm not sure how you find stuff like this. You kind of just have to poke around and hope for the best, apparently. Or figure out a good name. Or like hope that it has a good name. I'm actually pretty surprised we found it. Anyway, let's keep going. I'm happy that we got that figured out. Next. That was kind of cool. Oh, you know what's really funny is it says schema for our person type. Though the encoding won't work correctly with optional values, lists, or strings, each of these corresponds to a different base case of M1 through K1. And so we can provide some overlapping instances to clear them up. The easiest case is that of maybe A, which we'd like to describe as a field of A, though without calling emit required. I see. All right. What's funny is we're using this like really difficult code to explore how JSON schema works. That's how you do it. That's how you do it, folks. You're going to see that this code looks very similar to... Go there, please. Oh my goodness, I can't type. G schema M1S meta cell just name 2 3. Oh, hang on. Wait. K1 4. Okay, let me see if I can explain this. Not sure what all this aggressive inlining is about. Okay. So, what's wrong with this? Isn't it defined right here? Do I need to move this over? Do I need to move this in? Oh, it has to be in the same what's tab distance? Tab group block? I don't know what the right term is actually. Okay, so let's compare and contrast this. So there's going to be one difference is there's going to be an emit required function above this for the other case. So let's go find the other case. So we want basically meta cell. Okay, so note this A here is not a maybe A. Okay, so down here we have a maybe A. So this is an you're overriding the behavior if there's a maybe A. Okay, so this is the generic one. So that code looks familiar. And then the only thing we change is this emit required thing. And I don't remember exactly what emit required does. I think it just prints out the tell. I don't remember what tell means. Oh, that's something for writer. So this just gives you that list at the beginning of what's required and what's not. So essentially we're just leaving out maybes because they're not handled correctly. Okay? So yeah, that looks fine to me. I'm not going to say I understand every piece of this code, and that's true for a lot of the things above. In fact, generally speaking, I still would like to understand writer better, but we're going to do that with the other book we work on. But we're going to finish this book first because I've gone down to streaming 2 days, and we're working on that exorcism project as well. So next, okay, so that should take care of that, and that also means we can remove this nonsense. We don't need this anymore, but let's keep it just for let's put a note here. So experimenting with the idea of writing maybe out. I don't know. This is actually really cool too, right? Because you can just recursively call this function. So like it just does what you expect it to do recursively. I still think that that is like fundamentally amazing. You just don't do things like this in other programming. Well, okay, the other ones that I use on a daily basis. So experimenting with the idea of writing maybe types prefaced with maybe. And that also means we don't need first class families, but we'll just leave it there. Okay, where were we? We're down here. So we're gonna basically do this same thing, but not for maybes, but lists. So you probably can just do like this. And just for reference, this just here has nothing to do with the maybe-ness of the type itself. It has to do with this meta selector thing. Okay, and we need some other pieces. So to JSON type. Okay, that makes sense to me. Where? Oh. Do. We're probably gonna have to do this pure thing at some point. I just don't know when. So we'll just leave it there. So now we're going to emit required because it's gonna be not a maybe type. It's gonna be a list type. So it's gonna be required. Then we're gonna say let inner type equals object items make type object of A. Nice. I guessed that. I'm proud of myself. And then we in. Oh, we don't in. Hang on. Then we do pure make property obj dot merge objects inner with make object at list A. Okay, so I've actually never seen this style before, but I kind of like it. What do you think? Unexpected do block. What? What does that even mean? Didn't we do something like this before? Maybe I'm missing something? Known symbol. Yeah, that looks really nice, right? Instance overlapping. Known symbol. Meta cell. 1, 2, where? G schema equals do. Let's see if this is one of those strange... it seems to not like this do. Indentation and the do block. Shouldn't it... Do I need to indent it way further? Try and put it on one line. Put what on one line? Sorry. Oh, I see what you're saying. Okay. See if it somehow is unhappy about this. No, that's fine. I'm up for guessing at this current point in time because I don't understand what it's complaining about. Let me move this over. Here, make property, merge objects, make type obj at A. Yeah. Let's see if Stack tells us something else. Something a little easier. Am I missing something really dumb? This is how you let, right? Or am I insane? Or is something wrong there? What if I just put this on one line? Does that do anything for me? Probably not, but like... Yeah, it's really oh, okay, so yes. It has something to do with this let. Weird. What if I put this way out here? Okay, So yeah, it's something about the object here. So, you know, this really should probably be like the following, but then at that point you might as well just do this. What if we put a $sign there? What? It really doesn't. If I put this out here, is it fine? Redundant $sign. Okay. This is one of those cases, I think, where GHC is just having trouble with the indentation, which is fine. It happens. But that one's kind of weird. The error was weird. Now, do these just need to be past the do? Can I move them back one further and is it okay? Yep. Yep. I think I can align it here and it will be okay. And anything less than this is bad. Nope. Oh, you think it's the I? Maybe it's here. Yep. Yeah, you're right. Well, actually, it doesn't like this, so it's got to be probably past the I. Yeah. Interesting. We learned something new, I suppose. So what happens if, well, we can't format this because our formatter won't format code like this. That's kind of interesting. I'm not sure that this is 100% necessary. Let's just put it on the same line to avoid confusion, but what does object take? It just takes a list, right? Can you just write like object pure? Probably more typing, but it's the same thing. Just weird that you put one thing in a list, I suppose. All right. Neat. That's pretty cool, actually. Very weird error, though. Very confusing error. The next one is just apparently strings? Hang on. Oh, it treats strings as arrays, apparently. No, it doesn't. Maybe it did in the version that he's using. Catches strings first. It seems okay. Anyway. Okay. It says, and we're done. We successfully used the metadata in ghc.generics to automatically marshal a description of our Haskell data types into JSON schema. We didn't need to resort to using code generation, which would have complicated our compilation pipeline, and we've written nothing but everyday Haskell in order to accomplish it. I'm not sure that you could call this everyday Haskell, but at some point it'll be everyday Haskell. So let's see if it works, I guess. Do I have this thing going? Yeah. So FG1, reload. Whoops. Reload. And then we should be able to write the... Oh, I see. I broke... apparently I broke a character. No instance. Yeah, I broke the way strings work somehow. Because I overloaded. I think it's because I overloaded this. This instance gets hit first. So we gotta fix that. Whoa. And just need known symbol. Here. Neat. Okay. So yeah, so essentially it broke this because of the character problem. So now we can just do now this will just uh override that for strings. Override this instance for specifically strings. Although it's kind of interesting that like it uses the more specific type first and then works its way to the more generic type, which is this one. So that's kind of interesting, right? We're not 100% sure how it does that, but the compiler is there for us. Shoot, I just realized I forgot to. I actually left GHCI again because I'm stupid. Actually, yeah. So set package. How does this work? Set package byte string. And then load source app this, and then import qualified, import ASIN, and doop, set x type locations. Bam. All right, so we should have required name, age, permissions. Done. Title, person, type, object, properties. Phone is type string. Age is type integer. Name is type string. And permissions are items, type boolean, type array. Cool. There you go. JSON schema from Haskell. That's pretty neat. It hurts my head, and it's been pretty hard. Okay, so it says, and as expected, some types fail with, in theory, a decent error message. Oh, no. Schema at bool. So, Simon, just for reference, because I didn't do any fancy type error stuff, that's all you see is just JSON schema doesn't support some types. I think that I could probably make it better real quick by doing the following. Oh wait, no, that's just this error, I think. So where's that error coming from? This or this? You're such a doofus. Okay. Nice. Okay. So, let me see if I can find that thing. So, if we do this, then we should be able to deal with that type error wherever it went. Here we go. With those funny things. So, but how do we is the question. Unfortunately, I'm not sure how to specialize this particular instance. Mainly because this isn't right. It's almost right. Because yeah, I don't know. It would be nice to specialize, but I'm not sure how. Oh yeah, it's just called optics, right? I think it's just called optics. That's called this one? Pretty sure it's this one. I think it's currently vaporware, but I think it's this one anyway. There's no source code yet, so as far as I can tell. Oh, wait. Anyway, we could look through this code and try and find type error, but I don't really know where it is. Yep, here you go. So yes, that's exactly what it does. Neat. I still haven't been able to play with optics, but that book is now available. Optics by example or something. So we're gonna do that book at some point. I contributed to the Patreon page, so in theory we should be able to do optics at some point. They look like they're pretty useful, and people seem to be pretty pumped about them, generally speaking. All right, neat. We learned stuff, I think. All right. So it says the next chapter is called Performance. It says, with all the fantastic things we're capable of doing with JHC generics, it's worth wondering whether or not we need to pay a runtime cost to perform these marvels. After all, converting to and from reps probably isn't free. I'm not going to read all of this. Okay, so it says there's good and bad news here. Good news is that usually adding inline pragmas to each of your class methods is enough to optimize away all usage of GHC generics at compile time. The bad news is that this is usually enough to optimize them. Wait. Oh, it's only usually enough to optimize them away. Since there is no separate compilation step when working with GHC generics, it's quite a lot of work to actually determine whether or not your generic code is being optimized away. Thankfully, we have tools for convincing ourselves our performance isn't being compromised. Enter the inspection testing library. Provides a plugin to GHC which allows us to make assertions about our generated code. We can use it to ensure GHC optimizes away all of our usage of JC generics and generates the exact same code that we would have written by hand. We can use inspection testing like so. Enable the pragma to the top of your module. Oh, okay. Let's try it. Apparently we can just try this. So we need a few things. We need template Haskell. Oh, I see. I get it. Hang on. Not in here. Okay, so this, and then we import this, and we need to import we have that test.spec inspection. We can write my schema type applications, and then we need another pragma that I've never seen before. Well, actually, that's not true. I've seen this before. Options GHC O -f plugin test dot inspection dot plugin. Weird. My schema value, we get that from ASIN. My schema equals schema at person. Inspect has no generics. All right, so this must type applications must promote so that we can get the type constructor at the kind level, I guess. Why is it highlighted like this? Okay, and then we can do vim package, and we need, obviously this probably should go in my tests, but I've already written it here, so inspection testing. Definitely have to build that. I've never used it before. We should move it. I'm going to move it to test. Oh, weird. You can't even put it in main. What? Nice. Okay, that's cool. So let's actually put that in a better place. I mean, I probably can do this like this, right? And then we just need to move 16 to... Oh, here. Dependencies here. Okay. Stack test. Yep. There it is again. So that's probably a better place for it anyway, so good. Easy as that. That's what it says, by the way. Now, in the course of compiling your module, if your generic code has any runtime overhead, GHC will refuse to continue. Unfortunately for us, inspection testing isn't magic and can't guarantee our implementation is as good as handwritten example, but at least it can prove the generic representations don't exist at runtime. In order to prove two implementations, e.g., for example, one written generically and one written by hand are equal, you can use inspection testing's equal combinator. The triple equal causes a compile time error. The actual generated core isn't identical. This is often impractical to do for complicated usages of GHC generics, but it's comforting to know that it's possible in principle. Okay, so a good rule of thumb is that if you have a polymorphic higher kinded type, your performance is going to go into the toolies, which I assume is like toilets in... I don't know what toolies is. I'm going to assume toilets. All right. What is a con extension? I don't know what that is. Does that mean something to people? Con extensions are universal constructs in category theory. Okay, so not something that we're going to understand yet. However, this gives me a great chance to plug... Bum-ba-da-bum. Here we go. We're going to start doing category theory for programmers on the third Monday of the month on this Twitch channel. But we're doing it with a group of people, so it's a little different than what we're doing now. So when I do these books, I do them by myself, obviously, but we're going to try and do category theory for programmers with a whole bunch of people. And they're basically from my local meetup group. So we'll see how that goes. I'm pretty excited about it. But you can follow along on that GitHub to view our schedule and like when we're gonna what we're going to stream if you want to follow along, and when we're going to stream. And we'll be accepting comments from chat if you're interested. So it's a book club for everyone, but the audio portion, the speaking portion, is only available to people from the local meetup. Yeah, it's pretty cool. Also, hey, new mate, haven't seen you in a while. Yeah, I'm pretty excited for the idea of book clubs. I hope that I can continue doing them with the group, because if we can figure out a good way to like have discussions about it, because it's not just going to be Haskell, right? That book is written in other languages, and I assume people, the original book is in Haskell and C++, and there's also another book that's C++ and Scala, as far as I understand. So, and I think there's an OCaml version being written and other FP languages. So, anyway, I don't want to limit it to one language, so I'm going to let people do whatever they want. And I might personally try and implement stuff in Swift just to do something different and play with Swift. So, anyway, here we go. So, this is something... Yeah, I don't understand Scala, but we have a professional Scala developer, so a few of them. So, you know, they're going to provide code, and we're just going to run it if we need to. or probably we'll just have them discuss it at a high level, and hopefully that will help us understand it. I can read it, I just don't know how to like run it effectively. So anyway, let's keep going. Con extensions. Lurking. No worries. So we need some language pragmas, as usual. I have, by the way, no idea what con extensions are, so don't ask me to explain this. What time is it? Oh, wow. We got plenty of time. I don't know what Yoneda is, or even how to pronounce it. I know that these things have something to do with category theory, but don't. Sorry, I can't really go any further than that. Okay. So it says, I think it has something to do with our JSON schema example, but what, I don't know yet. So it says, on the grasping hand, there is good news to be found. Reclaiming our performance from the clutches of too polymorphic generic code isn't a challenging exercise. The secret is to rewrite our types in terms of con extensions. So, okay. So instead of, let's write some stuff here. So rewriting two polymorphic code as con extensions instead of, what's up, crazy kitty? For all f functor f fa for all. Whoa. He's crazy right now. Yoneda fa. What are you doing, you weirdo? Can you hear him? He's really loud. Applicative? I have no idea what this means. Curried. So, at the beginning of the year, I set my goal for the end of the year to understand the tweets from Iceland Jack. I don't know if you follow him on Twitter, but he talks often about, I guess the same could be said about Edward Met. I'm not sure if you say Met or Met. I'm not 100% sure. But the goal is to try and understand what the hell their tweets are about. And I know for a fact that Yoneda is something that's talked about constantly. So maybe someday we will understand these things, but it would be exciting to understand them. And maybe a little bit of category theory will help us get there. Okay. So this is what we're going to do. Apparently these are the con extensions of functor, applicative, and monad. Yeah, I don't know enough about it, so I'm not even gonna. I can't even comment on that, new maid. Okay, so there's literally a package that does this for us. Oh, what jobs do I have? Oh, well, we can kill them. Okay. Package YAML. Nice. It says we'll talk more about these transformations in a moment. In essence, the trick here is to write our two polymorphic code in form more amenable to GHC's inlining abilities, and then transform it back into the desired form at the very end. Yoneda, Curried, and Codensity are tools that can help with this transformation. Consider the definition of Yoneda. Although why didn't this... Not giving me any errors, so... Sure. It didn't seem to restart for whatever reason, so we'll just force it to. All right, so this is kind of like reader. Reader? Yeah, way over my head as well. But instead of taking like an R to A, it's taking it's like the functor version of writer, not writer, of a reader, I think. Is that right? Am I thinking about that correctly? I think so. Right, we're given some function from A to B and an f of A, which is basically like an f map. So you're going to f map this function over fa to get fb, but it's kind of embedded in reader, I think. Yeah. An interesting similarity to fmap emerges. Okay. I'm just writing these out for myself because I don't really know enough about this. I've heard all of these terms before, but you know, I've not used them, so it's probably a good it's probably a good idea to just play with them a little before we step forward. So codensity. This time it's an MA. So it should be for all B, A to MB, MB. I think. Which looks a little bit like Monad. If you don't see it, not sure I can help you. And curried, which we use to transform polymorphic applicative code, also shows this pattern, although it's a little trickier to see. It's a lot trickier to see. This is not an accident. The functor instance for Yoneda is particularly enlightening, it says. Do you think we're going to be enlightened? I hope so. That would be cool. My cat is literally going insane right now. It's hilarious. So given a K, I want to see if I can do it. So I need to do something with Y. That gives me a B. And then this takes... No. Yeah, I see. Y takes an A to B. K dot... Alright, so K is what? K has type A to B. So this gives me an A to B. Or I'm sorry, B to C technically. Or some other types. And we compose that with an A to B. So yeah, this is a B to C. This is an A to B. And Y gives me... Let's... Hang on. Need rank and types. Whoops. Okay. So what's the type of K? I think it should be, yeah, B to C. Right. So, and F is A to B. Y is an A to B. So we generate an A to B and get an F of B out of it. Interesting. Okay. I'm cool with that. Okay. Note the lack of functor f constraint on this instance. Yoneda f is a functor even when f isn't. It gives us an instance of functor for free. Any type of kind, type to type, is eligible. There's lots of interesting category theory behind all of this, but it's not important to us. But how does Yoneda work? Keep in mind the functor law. Fmap f dot fmap g is equal to fmap f dot g. We know that. Sorry, beard hair. The implementation of Yoneda's functor instance abuses this fact. All it's doing is accumulating all the functions we'd like to fmap so that it can perform them all at once. As interesting as all this is, the question remains, how does Yoneda help GHC optimize our programs? GHC's failure to inline two polymorphic functions is due to it being unable to perform the functor, etc. laws while inlining polymorphic code. But Yoneda f is a functor even when f isn't, exactly by implementing the functor laws by hand. Yoneda's functor instance can't possibly depend on f. That means Yoneda f is never too polymorphic. As a result, acts as a fantastic carrier for our optimization tricks. Finally, the functions lift Yoneda, which has type functor f fat arrow fa, arrow Yoneda fa, and lower Yoneda, witness an isomorphism between Yoneda fa and fa. Whenever your generic code needs to do something in f, it should use lift Yoneda, and the final interface to your generic code should make a call to lower Yoneda to hide it as an implementation detail. This argument holds exactly when replacing functor with applicative or monad and Yoneda with curried or codensity. Weird. That was a little over my head, and I really wish that they showed an example of this instead of just telling me it. But maybe the goal was I should be motivated enough to try this myself. Not sure. Like, it says I need all this stuff, but then we don't do any examples. We just look at the types, which is a little unfortunate. I need examples. Otherwise, I can't really help myself. Okay. Yeah, so that's actually, we're done with chapter 13. So unfortunately that means I'm going to finish a little early tonight because I don't want to start another chapter. The next chapter, maybe, I mean, I'm supposed to stream for another hour, right? I guess we can probably get the next chapter started. Yeah, let's do that. Okay. We are on, the next chapter is chapter 14 on indexed monads is what it's called. We are almost done, actually. And then once we are done, we're going to move to Book of Monads on Tuesdays, and I'm going to keep working on Exorcism on Thursdays because I've been having fun with it. But I think, yeah, we only have 2 chapters left. Indexed monads and dependent types. Chapter 14. And we want to change this. This should be 1330, I believe. And we want to add this here. All right. We should probably make a generator for this, but like, I just have been too lazy to do it. Also, has my water bot been going off at all? Water bot? What's the matter with you? I drank a few sips of water, but not enough. I have a water bot. I noticed somebody just hopped on, so hey, how's it going? We're about to start a new chapter for Thinking with Types on indexed monads. So I'm going to update our title. Indexed monads. And I don't really know what indexed monads are yet, so we're going to learn about those and go from there, as usual. Generalized new type deriving. Instance SIGs. Polykines. Scoped type variables. Type application. Okay. Import control monad indexed or data coerce. Okay, so index monads are a generalization of monads that allow us to enforce pre and post conditions on monadic actions. They're a great tool for describing protocols and contracts at the type level. Despite these great uses, index monads have historically been hampered by issues of ergonomics, making this technique less popular than it might otherwise be. Okay, cool. By the way, because my water bot has not been going off, I don't know why. What if I just, I mean, it seems to trigger. Anyway, Bird Spees, it's magical if you hashtag ad. It's not an ad. I don't make any money. I just like it. Okay. Anyway. Apparently this has been really hard for whatever reason. Basically the ergonomics of using them. In this chapter, we will look at how we statically enforce resource allocation linearity. We will build a monad which tracks files that are open and requires them to be closed exactly once. Failure to adhere to these principles will result in the program not compiling. Interesting. That is called linear types, right? Resource allocation linearity. I think I've heard this before. Anyway, linear type systems where like if you give it an x, if you give the function an x, you can only use x once. Whereas we can write, in Haskell, you can just write functions like whatever, tupler, No, we can't do that. Right? So, this would not compile if you had a linear dependence on int, right? Because you can only use x one time, whereas this code uses x twice. So I have seen this term before. Apparently we're going to try and implement it now. I'm a little confused Oh, okay. So this index monad comes from a package called indexed. So let's go get it. 23g dash indexed. And I probably need to build that one. Okay. And it goes in extra depths? Yeah. Extra depths. Nice. Okay. So now we have this monad that we can use, and I'm gonna type it here. IX applicative and MJKB. Like looking at this, it seems like we're incrementing K or something because I isn't changed. Or incrementing J or something. I'm not sure how to say that correctly, but I'm sure we're gonna read it, but I'm just guessing. So it says iBind here is the enriched version of bind. Although note that it's had its first two arguments swapped. In addition to the usual M, A, and B type variables, right, A and B, because we're trying to get that. These other type variables correspond to the state of the monad at different times. So essentially, yeah, so J, K, or well, I, J, and K here have something to do with state of this monad. Although I'm not sure why we need two of them yet, so we'll see how that goes. An indexed, oh, probably because we really sure why. We'll have to see. An index monadic action, MIJA, this one, is one that produces an A with precondition I. That makes sense. So it's like I is initial and J is, or not, pre and post conditions. iBind works by matching up the post condition of action MIJ with the precondition of another MJK. Okay, so when this action is performed, we need to have a post condition J, which matches the post con. Yeah, no, I don't think this is a range yet. I'm not 100% sure, but so yeah, so this is a pre and post condition. So this post condition, when we perform this action, must match with the result type here, because the this result type must have a precondition that's a J, right? The post condition of this action is J, then the precondition of this action must be J, and then the post condition of this must be K, so the post condition of this must be K. So you start with the precondition I, you end with the postconditions K, and you convert your A to a B by putting these things in order. Does that make sense? A lot of people just hopped in, so hello everyone. We're working on chapter 14 of Thinking with Types, which is just this book here. You can get it online if you're interested. There's a link I can give you, and basically this is talking about monads in a linear type system. So if you don't know what a linear type system is, I'll explain it again a little bit anyway, because it's important. I should leave this up for people that hop in. Okay, so keep in mind Haskell does not have a linear type system, so this is perfectly valid. Something with a linear type system would have some sort of annotation on this that says this is linear, okay? If this is listed as a linear type, I can't use it twice in the definition, okay? So if I have x here once and I annotate this as 1, I can only use it once in its definition. So that's what a linear type system is. Okay, and then let me say this out loud again because it's important. So we start with a monadic action, which has preconditions I and postconditions J. We essentially map in another function that produces an effect, but it will require the preconditions J to be met because the postconditions are J here, and then it will create a new set of postconditions K, and that will get pushed out into our result type. So if we start with Mij, we are basically linking the J through to the new action to create a K, and then we end up with an Mik, so the preconditions of I, postconditions of K and B, but we're basically enforcing these things to happen in order. That's what this is doing. I feel pretty confident that that's the case now. So that's cool. This chapter is already, I feel like, is already starting off a little better than before, just because I feel more attached to what's going on. And also I've wanted to investigate some linear type system for a little while. Anyway. Okay, the index package provides the ix monad type class, but doesn't actually give us any instances for it. Most of the time, we simply want to lift an underlying monad to have this enriched index structure so we can define a type to help with that. Unsafe run ix. We're scaring people away. Which I'm really not surprised of. This is pretty hard stuff. But this is what I want to learn, so fortunately they're kind of screwed if they, don't want to watch this level of Haskell. But we will start doing much lower version, not lower, that's not the right term, much less intense versions of this pretty soon. Okay, so I think that this deriving gets done by this generalized new type deriving, and it can recognize that, I guess, M and A is a monad, so it can just define everything. And then we just sort of have these carriers that I suppose we're going to deal with later. Carrier? I think that was the term that they used. Yeah, the carriers for our pre and post conditions. Can I move this over? Yeah, I kind of like that a little better. And then should I do this? Maybe we can just... Is this too much? I don't know. Might be too much. Need to see what our formatter does for us. At some point, I'd like to run like Ormaloo, or well, Ormaloo is not ready yet, but you know, H format, these sorts of things, to see if they deal with these files better. Oh, also, before I forget, we had another follower 5 days ago, so I think they were outside the stream, so I don't know if I shouted them out. So that's So Very Sour, who I know hangs around in the Soding stream occasionally. Also, Horrible Cow, also followed. So thanks to So Very Sour and Horrible Cow. Hopefully they come and hang out sometime. We'll see. Make sure IX is defined as a new type rather than a data. The aggressive proliferation of type parameters in IX might be self-evident to some, but deserves to be explained. I don't think so. We've explained them already. Index monads have their own index version of the standard type class hierarchy, so we will need to provide instances of all of them for IX. The first two can be implemented in terms of their prelude definitions, since their types don't conflict. Excuse me. Oh, we need to, I see, we need to implement the indexed versions. We don't need to implement the general versions. We can just get those. Oh, right. Their names are their names are very descriptive of potentially negative things. But yes, those are their actual Twitch handles. That's funny. It took me a second to get what you were saying. IXM where IMAP equals FMAP. Okay, so for functor and applicative, well, for functor, we don't need to worry about this indexing, right? And I don't think we need to worry about it for applicative either, because as we've discussed previously, the beauty of applicative is that the order doesn't matter, but we might have to do some type like rodeo to make this work. The place where this matters is the monad. Oh, sorry. This isn't called IX applicative. It's called IX pointed for some reason. Oh, okay. I see. So they have this pointed class that I don't know what it's for, but I guess it gives you I return only. But okay. Now we do the actual applicative. Wow. Oh, I see. So people are putting these in line with this, I guess. Well, I'll break this down in a second. J, K, A, M, I, K, B. Oh, sorry. This is supposed to be an arrow. Whoa. Okay. So first, let's move this over so that these line up a little bit better. Okay, so we are going to give this thing M, which has whoa. Okay. So basically, this scope type variables and instance sigs give us access to, these A and Bs, which we need. Trivially coerce. Okay. So if I remember correctly, okay, so let's look at this first. So we have a function wrapped in an index with preconditions I and postconditions J. So we want to, that needs to be our first argument to M here. Or this is our M. Wait, no, it's not our M. Why does this have 3 arguments? This is just defining a type. This is specializing the type of this. With the particular applicative, and then this is your input type and that's your output type. Right? We should go look at the type of that because it's going to be helpful. But I really wish I could leave this open, but I can't do split screens on stream anymore because Terminator tears really badly. Give me a second. So if we do set X type applications, it's 3. Three what? It only has 2 arguments. Yeah. No, I'm okay with that. The reason we're giving it F, A, and B is to specialize the type. So that's why when we do M, A, and B, well, we can, no. Hang on. I gotta get this cat out of here. Back here. Yeah. Okay. Since, oh yeah. Okay. So, that I understand. Andre is feeling apparently a little unloved, so you can say hi. Hi. This is Andre 3000. He's my very cute cat, but he's insane, so I have to keep him exercised. He was running around like a maniac earlier. So we could do like whatever, maybe int 3 stacks, yeah. Int. Let's use something else, integer, just to see the difference, right? So all we're doing is specializing the types and then filling them in. So that's what that piece is doing. Yeah. So we're coercing the apply to the specialized version. Okay, so let's not, yeah, this is just giving us the specialized apply and then coercing it to the index type, right? I think that's the idea. And then, so we have our preconditions for our function and our postconditions for our function. We have preconditions for the A and postconditions for A. So then we get the preconditions for the function and the postconditions for its application. Right. Is it right? Yeah, I think that's right. You're basically just sandwiching J. I mean, it's obviously right, but I'm trying to make sense of it in my head. So J is just implied. I guess. Implied? It's both a precondition and a postcondition in different places? I don't know, let's keep going. Eventually we're going to see some uses of this and hopefully it will make more sense. Apparently we're going to do... It also looks like we're actually going to mess with the syntax of Haskell from what I'm reading here, which sounds insane. So that's cool. We'll see how that goes. Okay, so IJKAB, yep. A to MJKB MIJA MIKB. Coerce right, because the arguments are flipped. So you're using flip bind. I assume there's a reason that they're flipped, and we're going to learn that at some point, but... Okay, finally, with all this machinery out of the way, we have a working index monad to play with, but working directly in terms of iBind seems tedious. After all, do notation was invented for a reason. Historically, here we were faced with a hard decision between two bad alternatives. Write all of our index monad code in terms of iBind directly, or replace do notation with something amenable to index monad via the rebindable syntax. However, the latter option infects an entire module, which meant we were unable to use regular monadic do blocks anywhere in the same file. If you're unfamiliar with rebindable syntax, it causes fundamental Haskell syntax to be desugared in terms of identifiers currently in scope. For example, do notation is usually desugared in terms of prelude bind, even if that function isn't in scope. In contrast, it says this extension is rarely used in the wild, and its finer uses are outside the scope of this book. Okay. The index monad situation today is thankfully much better. We now have the do notation package, which generalizes do notation to work with monads and index monads simultaneously. This behavior is enabled by adding the following lines to the top of our module. Okay. Rebindable syntax. Hey, look, that works now. Ooh, yes. More stuff to read. Oh yeah, I've seen some of this, but we'll save this in our Haskell list and play with it some more. I think we're gonna play with it now, so see how this goes. Although, interestingly enough, this, as soon as you turn that on, your code goes bonkers, which is kind of funny. Oops. Language dot Haskell. Can you import like other languages syntax? Seems weird. Prelude. Hiding. Monad. Here. Okay. So 20G. Do notation. I think is what it was. Yep. Let's see if we need to build anything. Okay, so warning. Oh, well, fine. Do. Uh-oh. Okay. Do not deduce monad M arising from use of pure from the context applicative M. So for, oh, I must have not changed something. Yeah. Oh, wait, no, this is applicative. Or is, wait, no, this is supposed to be monad. No, I said I returned. And then that needs monad because we're using pure here somewhere, I guess. How? Not really sure. Oh, probably because it's defining pure or something automatically behind the scenes. Okay, anyway. If you're importing it into a file that defines IX, make sure you to use pure from prelude when defining IX pointed. Oh, okay. So I think we can make this go back to applicative if we change this like so. Okay, is there a way to, do we just do hiding here? Oops. Does that cause anything to fail? Okay, neat. Okay, so I'm going to assume that, yeah, I just need to reload like the the packages. I'm not sure how to refresh those. Probably could do like Control M or something, not Control R, to get everything to refresh. But anyway, so if we do type do undefined defined, not sure why I need two of them, we get monad M and B. If we then turn on rebindable syntax, and we do the same thing, nothing happens. um, did I miss something? I think the behavior of this changed, maybe? Like it might work inside of the module, but not here. I'm not 100% sure. Um, Again, like there's some discrepancies like this in the book every once in a while. But it is what it is. Okay, so now we have this library for index monads. And now we're going to like use it probably in here. So we're going to rename this to ix monad. Okay. Oh, now what do I need in here? Probably all of these. Generalized new type driving. I don't need instance sigs, so I need this. I need this is too many of these. Okay, we need those things. We need this. We'll put these imports here, I guess. Monad index, data coerce. We need first class families. We need typelets. Apparently we need natural numbers. typelets. We have our index monad down there, and we need the do notation thing. We're gonna hide pure. We need prelude, hiding monad. We need import system. Need to import system IO hiding. Oh, whoops. Open file handle. Okay, what are we missing? First class families. Let's start there. 25G. First class families. Build. That's it. Nice. Okay. Now what? Alright, one particularly compelling use case of index monads is ensuring that actions occur in the right order. In this section, we will write an index monad that allows you to open file handles and requires you to close each of them exactly one time. Anything else will refuse to compile. In order to implement such a thing, we'll need to track whether a file handle is open or closed. We'll need to do it at the type level. The dumbest possible thing that could work is to keep the type level list whose elements represent the open files. As we open files, we can insert into it, and as we close them, we can delete from it. Elegant? No, but it will get the job done. We'll also need a means of generating unique keys for file handles. A strictly increasing nat will do the trick, which leads us to this data definition. Okay, data, linear state. Okay, linear state exists solely to be used as a data kind. It will correspond to the index of our index monad. Any given monadic action will be parameterized by the linear state going into it and the linear state coming out of it. We can show this directly by writing a new type around IX, which specializes the underlying monad and the kinds of its indices. I keep pressing the wrong thing. Oh, here, I can move this up as well. Neat. Okay, so work in the IO monad because we're reading and writing files, and define our input linear and output linear states. Okay. So again, because we've defined these, essentially we've already defined everything else. So good. Okay. The S. Oh, interesting. The S type parameter here is you is to be used with the st trick on page 91. I don't remember exactly how that works, so um, it's essentially a phantom type that helps prevent. It says it prevents file handles from leaking out of the linear context. I think yeah, it's a phantom type that basically doesn't allow you to link to linears or something. Anyway, I don't remember exactly. I'll look it up. And since we're supposed to be done very, very soon, I'm going to try and get something written. So, anyway, unsafe run linear is unsafe in two ways. It lets us run arbitrary linear computations, including incomplete ones in which we haven't yet closed all of our file handles. Additionally, it doesn't existentialize S, meaning file handles can leak out of it. We'll write a safer alternative later. We can make linear a little more usable by introducing OpenFile. This is pretty wild, by the way. Also, hello, new viewers. We're trying to write in Haskell, basically emulate. We're trying to emulate a linear type system in Haskell, and we're using the specific example of opening and closing file handles. So this isn't exactly correct, but we're essentially writing the open file um, alternative for a linear type system, and go from 6 back to 3 immediately. Wonderful. Okay. I'm not surprised by that, by the way. It's not weird. I think I did mean SIO. Maybe I didn't. Need the kind. Okay, let's go look up what a handle is. We're explicitly hiding a handle. But where does handle come from? Maybe that's not supposed to be hiding? Oh, it's hiding. Not sure where this handle's supposed to be coming from. What's going on, Oren? How are you? Glad to see you. Let's go look this thing up, I guess. Maybe it's just supposed to be a tick. Good. Now I want to write Google when I mean Google. So what's a handle? Ooh. Nick stuff. What are you trying to add to your oh, you're just like updating it totally. I see. Do all new packages, I assume. I don't understand. What is this handle and where does it come from? Oh, it's a new type. And it's defined on the next page. Got it. I would like this to be presented first personally. It just makes my life a little easier. Because I go, what is this handle? Because I'm building right away. Anyway. OpenFile's term level implementation merely lifts OpenFile. What's interesting about it is its signature. At 1, this up. D. Okay. At 1, which is this right here, we say this function can be used for any, next, and open. However, the post condition of OpenFile is that next is incremented. And open is appended to the set. I have not done Book of Monad lately, Oren, and the reason for that is we're only streaming 2 days a week now. I had to give up my Sundays because I need a little more personal time for the weekends. And so we're streaming longer now during the week. Tuesday, Thursday, we're going from 7:30 to 10:30. So I'm getting the hours back. But we're only doing it 2 days a week, and I don't want to switch books because it's going to take me time to mentally switch. So instead, we're going to finish Thinking with Types and then move on to Book of Monads. So I'll probably start doing, we only have 2 chapters left, so Book of Monads will be on Tuesdays starting soon, probably the next week or 2 weeks, give or take. So yeah, that's the plan. Does that make sense? Hopefully it makes sense. Anyway, I just need more time for myself on the weekend. Basically, I can't go anywhere, right? If I go home, my parents live about 4 hours away from me. And if I go there, I have to leave super early on Sunday to make it back for stream. That's all. And I don't want to do that. So, and there's other reasons, but let's just use that as the primary reason. So. Yeah, and it, like, I'm not changing the amount of hours that I'm streaming. That's still exactly the same. It's just when those hours are happening. So but yeah, it's things are generally better this way. Like I feel less burnout already, like even after a week, because like my brain just actually slept this weekend and chilled out, whereas normally I'm like preparing for stream and stuff. And it's not hard, it's just a little mentally exhausting. What is this? Parse error? Yeah. I'm constantly melting my brain, so yes, it's helpful to do this. Although, why doesn't this type check all of a sudden? This looks right to me. This is HLint parser. Interesting. What's this complaining about? HLint. One hint. Error. Alright. What's up, Swarm? How's it going? Yeah, it's the time. Like, if you say you're gonna be somewhere, you should be there, and I firmly believe that. So I don't want to like every other weekend say, look, I can't be there on Sunday. So instead, I'm doing my best to make a consistent schedule that works and doesn't ruin my life. Ruin my life is probably harder, like more aggressive than it actually is, but even just streaming 2 hours on Sunday is a surprising amount of work. All right. Anyway, this is some weird HLint error that I couldn't possibly explain to you. But I think we're actually probably gonna call it now because it's already 10:40, and